All right, we are ready. All right, so we're going to start with chapter 3. We're going to skip over chapters 1 and chapters 2 because those are dealing with things that we should know pretty well already by now, things that you've seen since like 6th grade, such as adding and subtracting, multiplying and dividing integers and rational numbers and whole numbers, order of operations, simplifying expressions, stuff like that. So we are going to start chapter 3 with solving one-step equations. So we're going to do one-step equations, and then today we'll also get into two-step equations and multi-step equations. So I'm going to give you a second just to copy down that definition for an inverse operation. If you can't read anything, let me know. It says an inverse operation is an operation that will undo another operation. For example, addition undoes subtraction, subtraction undoes addition, multiply and division undo each other. Those are inverse operations. So what mathematically will undo something is something's inverse operation. Can anybody tell me what the inverse operation is for squaring something? Taking a square root. Very good. So those are all examples of inverse operations. And we use inverse operations when we solve equations. Okay? So solving equations, we're solving for x. An equation is different from a mathematical expression because it has what symbol in it? Equations always have what symbol? An equal sign. So if you have an equal sign in a problem, it is an equation, not just an algebraic expression. All right? So let's say we want to solve for x here in example A. And if you guys will notice, I always number my examples by lowercase letters. Okay, with a little parentheses. So that's how I number my examples. I don't know why, I just have always done that. So x minus 5 equals 2. I want to get the x completely isolated. What does that mean if I want to isolate something? Get it by itself. So here's my x. I want to get that x completely alone on that side of the equal sign. So that means I have to get rid of that minus 5, right? So if I want to get rid of subtracting 5, what's the inverse operation for that? Add 5 to both sides. And the golden rule for equations is what you do to one side, you must do unto the other side, right? So x equals what? 7. Could we have done that in our heads? Yes, this is an honors class. If you just looked at that problem and you got it correct and told me x equals 7, I'm okay with this, okay? Okay, that's one of the joys of honors. Now, when we get to more difficult equations, yes, I'm going to require you to show me all your steps. Okay, but these little one-steppers, they're no big deal. So on B, what kind of inverse operation are we going to have to do to solve for that A variable? Subtract 7 on both sides. So A is going to equal what number? -3. So any questions on these two examples so far? And y'all are thinking, wow, this algebra is going to be easy, right? It is today. Write down problem C for me, please. (21 plus n equals -15. So kind of similar to problems A and B, they just put the variable in a different place. So here's my n, and I want to isolate that n on that side of the equation. So how do you think we are going to get that n by itself? Very good. It's a positive 21 hanging out over there. So to move it to the other side, I subtract it on both sides. And so n equals what? Yes, -36. Remember, when we're combining two negatives, we add them, and the answer will also be a negative. So they have the same signs, we add them. If they have opposite signs, we subtract. And the answer gets the sign of the bigger absolute value. So on D, how are we going to have to solve for that x? Yeah, add the 2. Very good. And x equals 13. So any questions so far? Are we good? It takes us longer to write down the problems than it is to do the problems right now, right? All right. So this time they're putting the variables on the right side of the equation instead of the left. Okay? So our job is still to isolate the variable, get the variable by itself on the right side. So we're not going to move the variable, we're going to move everything away from the variable. Okay? So write down problem E for me if you haven't already. So negative 27 equals x, or h minus 12, rather. So how do I get that h by itself? Well, they're subtracting 12, so the inverse would be to add 12 to both sides. Very good. My bracelet is hitting my screen. So those cancel. And why do things cancel? We haven't talked about that yet. Why do things cancel out when I do the inverse operation? Because that equals 0, right? Negative 12 plus 12 equals 0. Very good. Sorry, I didn't explain that earlier. But negative 27 plus 12 equals what? Negative 15. They're opposite, so we subtract their absolute values. And it's okay that the h is on the right, not on the left. If that bothers you so much and you switch them, that's fine with me as long as we're doing equations. Now, when we do inequalities in Chapter 6, you will not be able to just switch them, okay? So it's okay if you rewrite it h equals negative 15 instead of negative 15 equals h. I usually just leave them exactly the way they're written. So problem F, how are we going to solve for k? Good. Subtract 63 on both sides. Anybody tell me what 92 minus 63 is? 29. Very good. We didn't need calculators. And on problem G, if we want to solve that for x, what are we going to do? Add the 5. Very good. Get that x by itself. So what's 14 plus 5? 19 equals x. We good? All right, you guys, I believe, are going to try a couple on your own. So those where it says you try, that number 1 and number 2, that is your job right now on your paper. And I left the other 3 up there in case you're still copying. All right, if you get both of them answered, if you have both of them answered already, check them. Check your answers with a neighbor and make sure your neighbor and you got the same answers. Great. Some of y'all do lines for your equal sign. That is perfectly fine. It keeps them all lined up when you have more difficult equations, that's for sure. All right. Some y'all all together tell me what I'm going to do to solve for x in number 1. Add 11 to each side. And what is negative 5 plus 11? How can we check our work? Plug it in. Is 6 minus 11 equal to negative 5? Yes, it is. So raise your hand if you got x equals 6. Any questions? All right, number 2. How do we solve for x for 22 equals negative 20 plus x? Add 20 to both sides. And what is 22 plus 20? 42 equals x. Raise your hand if you got 42 for number 2. Very good. Any questions so far? All right, we're going to continue with one-step equations, except for this time we're going to use the operations multiplication and division. So far the only operations we have used to solve for a variable were addition and subtraction. So now we're going to go into multiplying and dividing to solve for a variable. So this problem H, negative 6x equals 48. What does it mean? What operation is being done with this negative 6 and this x right here? Yes, when I have two variables that are side by side, like that are a variable and a number side by side, that means they're being multiplied by each other. Okay? So if I want to get that negative 6 away from the x, what inverse operation am I going to use? Division. So I'm going to divide both sides by negative 6. And negative 6 divided by negative 6 equals 1. So that's why those cancel out. And give you just x. And what is 48 divided by negative 6? Negative 8. Very good. All right. And the next one says negative 28 equals 4h. So how do we get that h by itself? Good. And what's negative 28 divided by 4? Negative 7. Are we okay with dividing to solve for a variable? And I'm going to scoot over my J over here to give me some room. What's being done to the x in problem J? It's dividing by 3, right? So if I want to get rid of the 3 so I just have an x by itself, what do I do to both sides? Very good. You're going to multiply by 3 on both sides. So that cancels. And so x equals what? What is 7 times 3? 21. And again, you can check it. 21 divided by 3 equals 7. Okay. I have the next part blacked out because those are you tries and I don't want you working ahead. So this is K problem here is the same concept. They're dividing by negative 4. So how do we solve it for x? Good. So x is going to equal what? And you can check it again. Negative 20 divided by negative 4 is a positive 5. So any questions before you guys try a couple of these? We good? All right, y'all try those two problems. Sorry. When you finish, check your work, check your answer with a neighbor or a couple of neighbors. I live with it. Gotta have it. All right, can y'all help me solve number 1 for x? What do we do? Very good. Divide by -4 on both sides. That makes 1, so they cancel. So x equals what? Raise your hand if you got x equals -12 for number 1. Very good. Number 2, x over -3 equals 9. So how do we solve that one for x? Multiply by -3 on both sides. So x equals what? -27. Something also that I didn't make mention of, when you're solving an equation for a variable, make sure you don't just write a number for your answer. It's always variable equals a number or number equals variable. Okay, don't just say 12. Say x equals 12. Does that make sense? It's something we got to do when we have equations. All right. Fractions are our friends. We are not scared of fractions. In my class, we work fractions. We do not convert fractions into decimals. Okay? Never, ever, ever, except for maybe one time all year, will I tell you to change fractions to decimals. We don't play that game in here. We work fractions as fractions. Okay? So you will see lots of fractions in here. They're part of math. Not everything is a whole number. Okay? So we are going to solve one-step equations using fractions. And what you do when you have a fraction with your variable, they're stuck together, they're being multiplied. You're going to use the reciprocal of that fraction and multiply that reciprocal on both sides of the equation. And it's highlighted on my screen, so what do you think that means? It's kind of important. You might want to remember that. When you have a fraction times your variable, you multiply both sides by the reciprocal of that fraction. All right, everybody have that sentence written down? Let's practice it. The first one, example L, that's a cursive letter L, in case you didn't know what that was. Some people don't know cursive, but that's what it is. Because if I just put a regular stick down for L, it looks like a 1. So I want it to look like an L, so I do cursive. So 2/7 x equals 14. Okay? So let's just think about numbers in general. If this was a regular number, not a fraction, we would divide by that on both sides, right? Right? But when we divide by a fraction, don't we multiply by the reciprocal? Right? Dividing by a fraction, y'all remember keep, change, flip, right? So you got to multiply by the reciprocal. So that's why we have this rule that we will go ahead, if we have a fraction times a variable, multiply both sides by the reciprocal. So that's why we do that. Okay? Because multiplying by the reciprocal is the same thing as dividing by a fraction. So what's the reciprocal of 2/7? Yeah, a reciprocal, you just take the numerator and the denominator, and they change places with each other. So this makes 14 divided by 14, which is 1, right? This is called a multiplicative inverse property, okay? A fraction times its reciprocal equals 1. And so now we have x completely by itself on the left side of the equation. Now, how are we going to multiply that 14 times 7 over 2? Put it over 1. Yeah, when you have a whole number times a fraction, you can put it over 1. And then you can reduce diagonally, can't we? You could multiply across and divide by 2, right? Or you could simplify as you go. So do we have a pair of diagonals that will simplify? 14 and 2 are both divisible by what number? 2 is not divisible by 7. It's divisible by 2, though, isn't it? So if we divide them, I see what you're saying. You're getting that 14 divided by 2 is 7. I see that. So we divide them both by 2. 14 divided by 2 equals 7. 2 divided by 2 equals 1. So we change those two numbers into smaller numbers, and then we can multiply across our numerator and denominator. So for the numerators, we have 7 times 7 is 49. For the denominator, we have 1 times 1 is 1. And 49 over 1 simplifies to just plain old 49, right? So if you want to skip writing down this step, that is fine too. When you have all ones across the denominator, you know it's going to be just the numerator. All right. So write down problem M. Place 3/5 n equals -9. So how are we going to get rid of the 3/5 times our n? Multiply by the reciprocal of 3/5. And what is the reciprocal of 3/5? 5 over 3. So these cancel because they are inverses of each other. They make 1. Put that whole number over 1 over on the right side. So could I reduce diagonally any of these terms? The 3 and 9, right? So ignore the negative for just a second. What's the largest number that goes into 9 and 3? 3. What's 9 divided by 3? And what's 3 divided by 3? 1. So on top I have -3 times 5 is what? -15, and that's going to be divided by 1, right? So the answer is just -15. Does that make sense? Any questions about that? You good? I'm supposed to have a division bar right there. Sorry about that. Practice this a few more times. On problem N, they have is 2 fractions. And there's a common mistake that people make when they see an equation with 2 fractions. What do you think is one common mistake they might do? Yeah, instead of doing the one that's with the variable, sometimes people use the reciprocal of this one over here. Okay? We always, when we're solving an equation, want to get rid of the one with the variable. All right? So make sure when you do your reciprocal, you use the one that's with the variable to start with. So what is the reciprocal of 9 over 4? 4 over 9. So we're going to multiply both sides by 4 over 9. So these are going to cancel. And I believe I can reduce both of those diagonals, can I? Okay, let's do the 3 and the 9 first. What's the largest number that goes into 3 and 9? 3. What's 3 divided by 3? What's 9 divided by 3? And likewise, the 2 and the 4 are both divisible by what number? 2. So what's 2 divided by 2? 1. And what's 4 divided by 2? 2. And then you multiply across your numerator and your denominator. So on the numerator, we have left to multiply 1 times 2 is what? 2. And 1 times 3 is what? 3. And then after you do that, make sure that the fraction you're left with will not simplify. It's in simplest form. So is 2/3 in simplest form? Yes. So y equals 2/3 is our final answer. Any questions about that? All right. So problem O right here, 1/3 x equals -15 is actually very, 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 very simple. Because what is the reciprocal of 1/3? 3 over 1, which is what? 3. So technically, I just have to multiply both sides by 3. And since that's an integer over there and not a fraction, it's going to make sense just to do it as a single number. It's one whole number. Now, if it was a fraction over there, I would use my 3 over 1, right? And what is then -15 times 3? -45. Okay. All right. I want you guys to try these two on your own. Pretty please. Use your reciprocals. No decimals allowed. If you are finished working these two problems and your neighbor is finished, y'all may check your work. If not, keep working. I'm not rushing you. Everybody check with somebody, even if you have to check with more than one person, that's fine. How are we going to get more comfortable with fractions? We're going to keep practicing, right? How do I get good at anything? We practice. How do we get good at basketball or football or playing an instrument? Got to practice. All right, so y'all help me out. Number one, 2/3 n equals 12. How do I solve that for n? Multiply by 3/2 on both sides. So those cancel, and I put 12/1. And do the 2 and the 12 reduce? Yes, they're both divisible by, and what's 12 divided by 2? And 2 divided by 2. Multiply my numerators and denominator. Oh, that's a 1. Sorry, got ahead of myself. 6 times 3 is what? And that will be 18/1. So my answer is n equals 18. Raise your hand if you got n equals 18 for number 1. Excellent. Okay? Even if your neighbor helps you and you get it right, we're good. We count. Okay? All right, so number 2. 8/3 m equals -4/5. So how do we get that m by itself? Multiply both sides by 3/8. Excellent. All right, and then the left side cancels. Leave me with my m. And does anything reduce diagonally on the right side? The 4 and the 8 are both divisible by 4. So that's, what's 4 divided by 4? And 8 divided by 4? 2. And I have a negative times a positive will be a what? Negative. 1 times 3 is over 5 times 2 is 10. And double check, does 3/10 reduce anymore? No, it's simplified. So the answer is m equals -3/10. So raise your hand if you got that one correct. Very, very good. And congratulations, that is the first section of the book that we have covered in Algebra 1. So now we're going to go to Section 3.2. You don't have to start a new page of notes unless you want to. But just label it. This is section 3.2 now in the book. So all of those were one-step equations. We only had to do one operation, one inverse operation to solve for the variable. Okay? So these will be two steps, so they will take how many operations? Two. Now, if I say the word operation, what am I talking about? That's an equation. Equations have equal signs. So what's an operation? There's a bunch of them. Yeah, add, subtract, multiply, divide, square, square root. Those are all mathematical operations. Okay, so these will take more than one operation, two specifically. So the game is still the same. These are still equations because they have equal signs, and they all have one variable, and our job is to get that one variable by itself, to isolate it, get everything away from it. Okay? These are two-step equations. A lot of times on two-step equation, the first thing you will do is add or subtract. Most of the time, the first thing we will do to get a variable by itself on these type of two-step equations is to add or subtract. So on problem A, here's my M. Here's my M. And I want to get that M by itself. So what do you think we're going to do first? Yeah, we're going to add 17. Because I told you most of the time we're going to add or subtract first. So then that leaves me on the left side with 7M equals, what is 60 plus 17? 77. So now we have an even simpler equation left. 7M equals 77. How do we solve that for M? Divide by 7 to get the M by itself. And M equals what? 11. So that's my final answer. Yes, you can check it. 7 times 11 is 77 minus 17 does equal 60. Okay? Now, I'm not ever going to require you until we get on into the semester to check your work on paper, but it's always a pretty good idea to check it in your head or with your calculator. All right. Write down problem B, please. 18 equals 5n plus 3. So what's my variable? N, and it's on the right-hand side of the equation. So what do you think we're going to do first to isolate that n? Subtract 3 on both sides. It's a funky looking 3. So what is 18 minus 3? So I'm left with 15 equals 5n. And if I want to get that n by itself, what do I do to both sides? Divide by 5. And what's 15 divided by 5? 3 equals n. And again, we can check it with our brains. 5 times 3 is 15. 15 plus 3 equals 18. So that one is correct. Okay, C is another two-step equation, but it's written just a slight bit differently. So it says x divided by 2 plus 5 equals 11. So what do you think we're going to do first to get the x by itself? Subtract 5. So x over 2 equals what? 6. So what's happening right here with the x and the 2? What operation is occurring? That's division. So how do I get rid of the 2 to solve for x? Multiply by 2 on both sides. And x equals 12. And again, we can check it. 12 divided by 2 is 6, and 6 plus 5 does equal 11. Problem D is the same concept. X divided by 4 minus 3 equals 2. So first we're going to add 3 to both sides. Very good. So x over 4 equals what? And how do we solve for x? Very good. And x equals 20. Check it in your brain. Does it work? Is it true? Yep. 20 divided by 4 is 5 minus 3 is 2. Good. Very good. All right. These are slightly different now. How is problem E different from problem D? Yeah, it's multiplied times the fraction instead of the variable is instead of just dividing by a number, right? So on problem E there, 3/5 A plus 19 equals 16. How are we going to get the A by itself? What do we do first? We're going to subtract 19 on both sides. So that gets me 3/5 A equals what 16 minus 19? -3. Okay, so now it's like we got a whole new equation here. 3/5 A equals -3. How do we solve that for A? Exactly, we're going to use the reciprocal of 3/5, which is 5/3. Those cancel over here. I'm going to put my -3 over 1. Did any of those numbers diagonally reduce? The 3 and 3 are both divisible by 3, right? So 3 divided by 3 is 1. 3 divided by 3 is 1. For my answer, I'm going to have a negative times a positive equals a what? Negative is going to be negative what? Yeah, 1 times 5 divided by 1 is -5. Any questions about problem E? All right, problem F is the same concept. What do we do first on problem F to get the n by itself? Add 8 to both sides. So 3/2n equals what? It's 11 plus 8. 19. Good. And so how do I solve for n when I have the 3/2 beside it? Multiply both sides by the reciprocal of 3/2. And what's the reciprocal of 3/2? 2/3. Do it to both sides. And put 19 over 1. Does anything reduce, though? No. So just multiply across, numerators and denominators. So what's 19 times 2? 38. Over 1 times 3? 3. Does 38 over 3 reduce? Well, 3's prime, right? So does 3 go into 38? No. So it does not reduce. Good job. Oh, I didn't cross this one out. I meant you to save that U trial once you're working ahead. But look at G. G is a tiny bit different. And I told you guys that most of the time for this class, when we see a two-step equation, our first job will be to use addition or subtraction. Problem G right here is an exception to that. Okay? What do you think I can do first to get x by itself in that question? Right, that x plus 2 expression is all being divided by 5. This whole left side of the equal sign is being divided by 5. So the first thing I can do is get rid of the 5 on that side by multiplying both sides by 5. Is multiplying by 5. So that gives me x plus 2 equals what? -15. And then how do I solve x plus 2 equals -15? Very good. So x equals what? -17. That doesn't look like 17. It looks like 77. So any questions about that? All right. So that next problem has a star beside it. What do you think that means? No, that means that you guys get to try it. That's a you try without me writing you try beside it. So y'all try the star problem. All right, when you get your answer for x, go ahead and share it with a neighbor. All right, what do you think is the first thing we should do on this problem? Add 7 to both sides. So what is negative 1 plus 7? Equals x over 4. And so how do we solve for x now? Go ahead and multiply by 4 on both sides. And what is 4 times 6? 24 equals x. Raise your hand if you got 24 for your final answer. Or x equals 24. Very, very good. I'm proud of you guys. All right. These next little section of notes right here, we're going to solve equations by combining like terms. Raise your hand if you've heard of the term like terms before. I'm sure we have, okay? Like terms are when we have the exact same variable with the same exponents. Same variable with same exponents. So is a x squared and an x like terms? No, an x squared and an x is not like terms. They're both x's, but they have different exponents. Okay? So they have to have the same exponents with the same variable. Are two integers like terms? If I have two integers that don't have variables with them, like negative 5 and positive 3, are those like terms? Yeah, because their variable is they don't have a variable, right? They're called constant terms. Okay? So if the two numbers don't have variables, they both don't have variables, they're also like terms. So problem H here has two x's on the left side of the equal sign. So they are like terms if they are the same side of the equal sign. Okay? So they're not really considered like terms when one's on the left side of the equals and one's on the right side of the equals. Okay? But if they're on the same side of the equal sign, then they are considered like terms. And the way we combine like terms is by adding or subtracting their coefficients. Now, what is a coefficient? Number with a what? A variable. Okay? So the coefficients here in this problem are the 7 and the negative 4. Okay? So coefficients are numbers that are stuck with a variable, that are multiplied times a variable. So we're going to solve this one by combining like terms. They both have an x on the left side of the equal, so the 7x and the negative 4x are like terms. So when you combine them, you just do what the symbol in front of the variable says. So this is a positive 7x minus a 4x. So what is 7x minus 4x? 3x. So you combine them and you get 3x. If you want to leave your line there, that's fine. Equals 21. And then how do you solve that for x? Divide by 3. And x equals 7. So if you put your lines on your equal sign, that is fine with me. I don't care. If you don't like your lines, you don't have to put them. But I can see where they help. Is that one of y'all? Or is that the door? Okay. Just don't knock on the wall, whatever you do. Okay? All right, 5a minus 7a, are those like terms? Yeah. So what do I get when I combine those two? Negative 2a. Very good. Equals 4. And then how do I solve that for a? And so a equals what? Negative 2. Any questions? There's a star. That means you guys try that one. All right, how do we solve this problem? Sorry, didn't have a number. What do we do to solve this one? The like terms, my d. So what is 5d minus 9d? So negative 16 equals negative 4d. And how do I solve for d? And what's a negative divided by a negative? A positive what? 4 equals d. So raise your hand if you got 4 for d. Any questions? Guess what? We're going to do another section. Because y'all are geniuses. And we have 25 minutes. So we did one-step equations in section 1, two-step equations in section 2, and today in section 3 we're going to do multi-step equations. Now what you're going to see today is every time the variables are going to be on the same side of the equal side together. We're not going to do variables on each different side of the equal sign until tomorrow. So tomorrow we'll have variables on both sides. Okay? So we're doing everything with the variable on one side today. So look at problem A. 8x minus 3x minus 10 equals 20. Now these are called multi-step because they're going to be 2 or more steps. Okay? Multi means 2 or more. So, from what we just talked about, what do you think is the first thing we need to do on problem A here? Well, that's not what I would do. I would combine my like terms first, okay? Because it just makes it more simple to look at when you only have one variable. And since they're on the same side of the equal sign, they're like terms. So what is 8x minus 3x? 5x, and we'll copy everything else. Okay. So now what do you think we're going to do? Add the 10 to both sides. Very good. So then 5x equals 30. And then what do we do? Good. 5 by 5 on each side. And x equals 6. So it was probably one more step because we combined like term and then we added 10 and then divided by 5, but it still wasn't anything very difficult. So B is the same concept. Okay? What do we have on the same side of the equal sign? My variables have 2 x's, right? So they're like terms. So what coefficient is understood to be right here? 1. So that's a negative 1, right? So what is 9x minus 1x? And that combines my like terms for us. I'm going to erase my line. So what do I do now to solve for x? Add 7 to each side. So 8x equals 20 divided by 8. And x equals. It reduces, right? What's the largest number that goes into 20 and 8? 4. So what's 20 divided by 4? And 8 divided by 4? 2. Now we leave these as fractions, guys. We don't tell me that's 2.5. Okay? I only want decimal answers if the problem gives you a decimal. Okay? Improper fractions are A-okay. Okay? 2.5 is even acceptable. Please don't tell me that's 2.5. All right? Miss Isabel does not like decimals unless the original problem contains them. Yeah, mixed numbers are okay. I prefer improper, but because that's just one more step. Because sometimes people mess up converting it to a mixed number when they had it right when it was improper. Does that make sense? So improper is great because when you get to geometry and you get to algebra 2, you will see lots and lots of improper fractions with pi and trig and all that stuff. Now we haven't seen any like these yet today. What's different about these two problems than with anything we've seen today so far? The parentheses. Now, what do those parentheses mean? Okay, inside of them you would if it was order of operations, but since we have a variable, exactly. So these parentheses specifically mean for us to distribute the outside term times everything that's inside of the parentheses. Okay, so we're going to use distributive properties. So I'm going to copy my 7x. It does not change right here. And then I'm going to distribute right here. So distributing means I take that 2 and I multiply it times all the insides. So what is 2 times x? 2x. And it's positive, so keep the sign the way it's supposed to be. And what is 2 times 6? 12, and it's positive 12, so I write plus 12 equals 39. So any questions about how I use distributive property right there? Okay? And then I have like terms. So what is 7x plus 2x? 9x plus 12 equals 39. And then what? Very good. What's 39 minus 12? And then I divide both sides by, and it's 27 over 9 reduced. What? Any questions about that? All right, number D, problem D here. We got to be a little careful when we distribute this one because there's a negative in front. So it's very common for people to mess up and make mistakes when you're distributing with a negative in the front because people forget to do their signs. So just be careful of that. So again, we're going to copy the 4x because it has nothing to do with the distributing part. And then first we multiply negative 7 times x, and what do we get? Okay. And then we multiply negative 7 times negative 2. And what is negative 7 times negative 2? I'm telling you, the most common mistake on a problem like this is people putting a minus 14 instead of a plus 14 right there. Negative times a negative is always positive. And then that equals 26. Then what do we do? Like terms. What is 4x minus 7x? Negative 3x plus 14 equals 26. So how do I solve that for x? Good. So negative 3x equals, and then what do? Divide by negative 3. And x equals what? Negative 4. Any questions on these with distributive property? I was going to have y'all do a you try. Y'all just try number 2. Save a little time. Just do number 2. I'm going to assume if y'all can do the more difficult one, y'all can do the easy one. And you may check your neighbor for an answer when you're finished. Yes, sir.
Yeah, really important question. How do you put a mixed number in the calculator? I forgot.
Why are you interrupting my class asking this?
I'm sorry, we were doing geometry and we all forgot how.
Okay, let me finish my lesson and I'll.
Yes, ma'am.
Okay.
You're gonna come back or?
Yeah, you're going to have to. It's okay. Okay. So What did we do first on number 2? Distribute. You do what first? Well, yeah. Me too. Okay. So then we're going to distribute the 3 times W plus 4, right? What's 3 times W? 3W. And then 3 times 4 equals 27. And then what? Like terms. What's 2W plus 3W? Plus 12 equals 27. And then what? Subtract 12. So 5W equals 15. And then what? And then W equals. Raise your hand if you got W equals 3. Very good. And I believe that's the end of our lesson. So